Hey guys, it's FunnyAnimatorJimTV, and welcome to the second part of my Super Mario Odyssey tutorial, how to make a Super Mario Odyssey remake in Scratch. So, a few things I want to mention before we start. Firstly, see this FPS counter up here? See the frames per second counter? The only reason why it is so slow and jumping between numbers like this is because I'm recording. If I was not recording, this would run at a buttery smooth 30 frames per second. Very stable, 30 frames per second. So, unfortunately, because I'm recording, it is very, very slow right now. Also, these placeholder costumes, like the simplistic Mario yellow ball and the Cappy in the ground, it all looks very simplistic, and there's no animations. These are just placeholder costumes. They are not going to be the final costumes that we're using in the project. I'm going to make another tutorial later on how to draw Mario costumes and how to import them if you can't draw them, and how to do all that stuff. So these are just placeholders, these Mario and Cappy drawings. And basically what we're going to be doing in this tutorial is we're going to be implementing Cappy. So you see, if I press Y and Cappy flies off in the direction I'm facing. Also, if I stand up against a wall, you see he stops when he hits the wall. If I press and hold Y, he stays in the same position. He scrolls across the screen. He stays in the same position for a while. And the only reason why it's so slow is because I am recording. So this is the code that we're going to be making today in this tutorial. You see this code, this piece of code operates Cappy. So that's what we're going to be doing. Let's start right away. So this is the project that we started our tutorial on. So the first thing I'm going to show you how to do is how to make that FPS counter. So we need two variables to do that. So let's make a variable. First one is going to be called FPS, and make it for all sprites. Say OK. And the second one is going to be called frame. And then here you can click this blue check mark to hide frame, because you want to leave FPS showing so you can always see it. So now, basically how this is going to work is we're going to put the frames per second counter right in this forever loop that we're always using, because this forever loop always checks every single frame, and that's what we want. So, first thing we need to do is, at the start of the project, we need to set frame to 0, because we're going to be setting frame to 0. And now, what we need to do is, in this forever loop, we need to change frame by 1 every single frame. And now, the way Scratch works is, there is a timer. They have a timer. So we're going to say if, and then we're going to go in the green section and then grab this operator that says greater than. And Scratch has a really accurate timer. It's pretty much always accurate. It's right here in the blue sensing category. Scroll down to timer and reset timer. So we're going to detect if timer is greater than 1. The timer deals in seconds. We want to check the moment the timer goes past 1 second, we are going to set a couple things. So we're going to set, first of all, we're going to set FPS to frame. We're going to set FPS to frame, and then immediately after that, we're going to set the frame back to 0. And how this works is, immediately every frame it's going to increment this frame by 1, and the moment after 1 second happens, also really important, we need to reset the timer at the start for this to work, and reset the timer immediately after all this stuff. That will reset the cycle, and however many times this, for whatever number this frame is, that's going to be our FPS. It's going to make sense. And you want to put this right inside our forever loop like this. Do not put it at the end. Do not put it after this broadcast frame and wait. Because if you put anything after the broadcast frame and wait, that will lower your frame rate. So put it at the top. Always keep the broadcast frame and wait at the very end of the forever loop. And now if we check it, let's see if it's working. You see we're getting a number, so that's good. Sorry that it's a really low number, because I am recording. That's the only reason why it's a very low number, because it's recording. But you see it's working now. So this is really useful. The reason why I want to make this FPS counter is because our entire project is going to be running in frames, not really seconds, because that's going to make it run really smoothly. And this frames per second counter is going to be really useful to tell us how long things should wait. This is not very stable at all right now because I'm recording, but if you're not recording, then it should be very, very stable. And mine always runs at 30 frames per second when I'm not recording. So that is all I wanted to do. That is how you implement your FPS counter. It's really, really simple. And now let's get on to making Cappy. So in order to make Cappy, first we need a new sprite. So hover over this, choose a sprite, and then paint one. Paint a sprite, and we're going to call it Cappy. So come right here, call it Cappy. And now here we can draw him. So let's just make it really simplistic for now. So let's make it a nice red fill color. Increase the saturation. Increase the saturation. And we have a black outline. So nope. No. We want an outline. Unfortunately, that's not working for some reason. So let's just make it like this. Sorry that it's really, really choppy because I am recording. And we're going to fill to make it red and make the outline. I wish I could make the outline. Okay, let's make the outline black. Unfortunately, I can't do that. Well, this will be okay for now. This will be okay. It's not perfect, but it's okay. And I'll make it a little smaller. Make it a little smaller after I do this and this. Remember, you don't have to make this perfect. This is just a placeholder. We're going to be changing this later. So I'm going to make it a little smaller and make sure it's about centered. And that's good. We'll use that for now. So, the first thing we need, first we're going to get a green flag clicked when green flag is clicked. And we're going to set the rotation style to left-right, just like we did for Mario, because if we don't have the rotation style left-right, then Cappy's going to be rotating like this. He's going to be upside down. So when we set the rotation style to left-right, you see Cappy is only going to be facing left and right, which is exactly what we want. So, set it to left-right. And now we're going to need a couple variables here. The first two we're going to need are very simple, Cappy X and Cappy Y. Cappy X, you can make it for all sprites. Cappy X and Cappy Y. Cappy Y, make them for all sprites. You can hide them. Cappy X and Cappy Y. And the next variable we're going to need is really important. Frames Cappy has been out. That's kind of long, but you can call it something else, but I think this makes sense. Frames Cappy has been out. Click OK. So what this variable is used for, since we're dealing with frames, we're dealing in broadcasts and frames, and this is going to keep track of how long Cappy has been out, when he should stop moving, when he should come back. It's going to be really, really useful. So, right away, we're going to set frames Cappy has been out to 0, because we're assuming that he hasn't been pressed yet. And we're going to hide it. We're going to hide Cappy. But that doesn't really matter, because immediately we're going to receive frame. When I receive frame. And also, another thing we need, I forgot to add it, we need a hitbox for Cappy. So we're going to duplicate it, and we'll just make this one a hitbox. So we're going to get a red, so we're going to get a box, make it black, doesn't have to be black. Let's see, and we're going to make it about, let's see, about that size. Looks good. Can make it a little thicker. And we're going to delete this. That is going to be our hitbox. We're going to call it hitbox. And let's see, is it centered? It needs to be centered. That's right. You gotta make sure it's centered. So I'm gonna make a line here and a line here, and then center it at those lines. So what about that? 1, 2, 3, 4, and we're gonna stretch this just a little bit. Right, 4 and 4, and that's 3 and 3. That's perfect. Now you can delete these lines. It's perfectly centered. You might as well center Cappy as well, based on the box. And there's our hitbox. So when I receive frame, you're gonna switch the costume to the hitbox, and at the very end of this, we're gonna switch it to our Cappy costume. So we're not gonna set it here right away, because that'll get caught on things if it hits up against walls and stuff. So switch it to the hitbox, and now we're gonna need an if-else statement. We're gonna need an if-else statement, and we should go into Mario right now. So we should go into Mario, because this is how we're gonna detect if Cappy has been thrown or not. So right around here, let's see, right around here, let's see. Okay, so right here, we're going to need an if statement to detect if key Y pressed. Not the actual thing here, remember, because we made it detect if we have multiple playstyles. So key up pressed, we're going to change it to key Y pressed. If key Y pressed equals 1, and remember how at the start we made this. Oh, we need a new variable. That's right, I didn't make it last time. We need a new variable. We're going to call it cap thrown. Cap thrown. Cap thrown. Make it for all sprites. That's very important, more so than ever now. Okay. And we're going to use this variable, cap thrown. We're going to get an and statement. We're going to get and equals if key Y pressed equals 1 and cap thrown equals 0. Remember, if key Y pressed equals 1, that just means if key Y pressed is true, if we are pressing Y. If this number was 0, then that would mean it's false. That's the way it works in programming. So if cap thrown is not true, so in other words, if we haven't thrown our cap, because we don't want to be able to throw our cap after it's already off. So if key Y pressed equals 1 and cap thrown equals 0, then we're going to set, this is really important, we're going to set cap thrown to 0.5. This is the way that I like to make it work. When we are actually throwing the cap, when Mario is actually doing the animation to throw the cap, and Cappy is moving forwards, he hasn't stopped yet, I'd like to set cap thrown to 0.5. When he is completely still and actually sitting there, just hovering, then that is when I like to set it to 1. Set cap thrown to 1. When he is coming back to Mario, that's when I like to set it to 0.4. That's just my method. You can do it some other method that you like, but this is the way that I like to have it. When he's completely not being thrown, then cap thrown is 0. When he's being thrown, then it's at 0.5. When he's completely still and hovering and out there, then it's 1. If he is coming back, if he's returning, then we have it 0.4. So this we're gonna put right here. We're gonna put it where? Where are we gonna put this? We're gonna put it right after this up pressed, after the jumping code. So we're gonna put it right here. So let's see. So that is gonna signal to Cappy. That's gonna signal. So that 0.5 that we set in Mario is going to signal to Cappy. We're going to detect that. So we need to detect if cap thrown is greater than 0.4, because cap thrown is going to be 0.5 when we want Cappy to be thrown. So cap thrown is greater than 0.4. So if cap thrown is greater than 0.4, so if cap has been thrown. So what we need to do here first is frames Cappy has been out is 0. So he hasn't been thrown yet. So we need to get an if equals 0. So we need to get if frames Cappy has been out equals 0. So if he hasn't even been thrown yet. So because we just started the project with it being 0. So if frames Cappy has been out equals 0, then this is where we're going to position things. So we're going to set Cappy X and Cappy Y, Cappy X and Cappy Y to player X and player Y. So we're going to set Cappy's position to the player's position. That makes sense, right? Because that's where he's being thrown from. Also, we need another thing. Point in direction. Where's point in direction? There's point in direction. Direction of Mario. Direction. Where's direction? Thing. There. So switch this stage to Mario and then switch this to direction. Point in direction. Direction of Mario. So that is going to be useful really soon. So the next we need another if statement. And this if statement is going to be used. Well, let's see. Actually, let's do a test first. So just put here, go to X. Go to X. This is going to be our script that we're going to be using all the time. We're going to be using, where's a minus? Minus, minus. Go to Cappy X minus N scroll X and Y, Cappy Y minus N scroll Y. That's going to position him on the screen. So for example, if we try this and just press Y, okay, well, we need to show him first. Show. Let's have him be shown. You can see there, actually. I need to, well, with this, we're going to change this later. So, if frames Cappy, the reason why that's happening is because we never changed this first. If frames Cappy has been out equals 0, then, so for example, we're going to change frames Cappy has been out by 1. So that way, now when I press Y, I need to have him show first. Show. You can see he's scrolling along the screen. If I press Y, okay, well, that's because we didn't reset cap thrown to be 0 at that point. So, let's just continue with the normal script. Let's just continue with what is actually in the code that I made. So we're going to need another if statement. This is going to be the time that Cappy is flying away from Mario. Not just he's going to be flying away from Mario before he stops moving. So this is going to be if frames Cappy has been out is less than 7. So 7 frames I want Cappy to be flying in the direction away from Mario for 7 frames. That's what I like to use. If you want him to be flying away for longer or shorter, then you can adjust this number as you please. So if frames Cappy has been out is less than 7, we're gonna change. This is why we set our direction earlier. We're gonna change Cappy X, because we're not dealing with any vertical movement yet. We're not dealing with any vertical movement when we throw Cappy yet. So change Cappy X by, we're going to need some things. We're going to need a multiplication, and now we're going to need a division. So in this multiplication bubble right here, we need to input the speed that we want Cappy to be moving every frame. So when I was tinkering with this, I liked 24. I liked 24. So that's what we're going to be doing. And you really have to tinker with these two numbers with this project, with the script here, to get it to exactly your liking. I like these two numbers, 7 and 24. So now basically how this is going to work is we're going to need direction. So where's that? Direction divided by absolute value of direction. So go to the green operators. And now down here, go to the very bottom, we get this weird block, absolute abs of direction. That stands for absolute value. You get a whole bunch of different functions, but we're going to be using absolute value of direction and put that in here. So basically, if our direction is negative 90, basically what the absolute value does is no matter whether that number is positive or negative, it always makes it positive. So direction divided by absolute value of direction will give us either 1 or negative 1, and then we can multiply that by 24, and that's going to give us our speed, left or right. And that is going to change right there. And then we can go to Cappy X minus next scroll X and Y, Cappy Y minus next scroll Y. And then at the end of all of this, we can change frames. Cappy has been out by 1 because he has been out for 1 frame. So here, oh, also, we need to set something at the start of this. We need to make sure cap thrown is 0. We need to make sure cap thrown is 0 because we want Cappy to be on Mario's head at the start. So we're going to show Cappy. Okay, right now he's just in a random position. We're going to press Y, and you see he shoots out in this direction, which is exactly what we want. He shoots out for a limited time, because we made sure that it's only for 7 frames, and he shot out at 24 pixels per frame in the direction we were facing, which is exactly what we want. And now this is also something really useful. We need to replace this if statement with an if-else statement. If frames Cappy has been out is less than 7, then we just do exactly what we just told it to do. Change Cappy by 24 times whatever direction he's facing. Go to X. Now, this is really useful for us knowing what state it's going on. So, set cap thrown to 0.5 when he's being flown out, and when he finally stays in his proper position, then we set it to 1. So if we look at that, if we check cap thrown here, and now let's show Cappy. Let's bring this out actually. Show Cappy. Let's show him. Now he's in a random position. Let's face that way. You can see cap thrown is 0. Now watch that number. See, it's 0.5, and then it gets set to 1. It gets set to 1 immediately after it stops moving, because it's past 7 frames. You see this frames Cappy has been out keeps going up. That's how this is working, because we're changing frames Cappy has been out every time we receive 1 frame, which makes sense. So, now you notice Cappy went inside the wall. He went through the wall. So how do we fix that? Well, we have to come here. We have to detect if we are touching collision. If touching collision. Right here. If touching collision. Then we need to put this right here, and we need to see change Cappy X. So we just did this movement, and apparently we're in the wall right now. We just did this change Cappy X and then position, and we're in the wall. So we need to back out of the wall. So we need to undo what we just did. We need to undo that. So minus 24. So we need to undo that. So if I show Cappy, he's in the wall right now, but let's just reset. So we do that, and he stops before he gets to the wall, which is exactly perfect. So, but he could be a little closer to the wall. So what we're gonna do, we're just gonna duplicate this, and we're just gonna do this by -12 to see if he can back out of the wall. And we did half of that movement. So if he's still in the collision, then we can back him out the full 24 pixels that we moved him in. That way he can be a little closer to the wall. Let's see, show. That way he can be a little closer to the wall, like that. That wouldn't have happened if we just did the 24 all at once. So we broke it up into two 12s, so he could be a little closer to the wall, like that. So, but now, okay, there we go. So, that is our basic Cappy movement for when he is moving out like that. And also, here, if it's out here, we need to make sure we show Cappy. We need to make sure we show Cappy, and we can make him go to front as well. Go to front. Where is that? Where is that? It's down here. Go to front and show. So that way we don't have to press that anymore. We can see he goes to front and he shows. Now, suppose we threw him, and suppose he comes back. Now he needs to be hidden. So what we need to do is, first we need to make a return animation. So, and also we can put costume 2 at the end of this. We can put our Cappy costume that we made to show instead of this hitbox. Instead of that hitbox. Because remember, we set our hitbox at the start. We run all this detection code. And then finally at the end, we switch it to the new costume. And that will, see, it makes it show the Cappy costume instead of the hitbox. That's really neat. So, otherwise, if Cappy thrown is greater than 4. Now, what we need to do is we need to add a detection if Cappy has been thrown for long enough. So this is where we use our frames Cappy has been out variable again. So, and we get an and variable, and we put our if cap thrown is greater than 4, and then we get an and then we get a less than, and we put if frames Cappy has been out is less than 50. I mean, not 50, 30. 30. So that would be 1 second if this were running perfectly. So if Cappy has been out for less than a second, then this code runs, but every time this frames Cappy has been out changes. So then eventually it's going to get over 30. So then at that point we need to hide it. We need to hide it, and we'll see how that works. I'm going to throw Cappy, and then you see this number is going to go up and up and up and up, and oh, it hit 30. So then it came back because Cappy had been out for long enough. Also, when we hide it, we need to do a couple other things. We need to set some things. We need to, first of all, set cap thrown to 0 because he came back. And also, we need to set frames Cappy has been out to 0. Frames Cappy has been out to 0 because he's not out anymore. And if we try that again, then you can see it's going up and up and up and up. It's 1. It's going up and up and up until it gets to 30. It resets, and cap thrown is 0, just as we want. Now, when we throw Cappy, the animation is kind of like, once it's over, he just disappears. He doesn't come back. So we need to add an animation for when Mario's coming back. For when Cappy is coming back to Mario. So the way that we do that is, first of all, we need to detect if Cappy has been thrown or not, or if Cappy has been thrown to get to this current position, or he is just being hidden for now. So we need to get an if-else statement. In the else, you put this hide stuff. And now, the way we detect whether Cappy has been thrown to get to this position or not is we get our frames Cappy has been out, and we see if that's greater than 0. If that's greater than 0, then that means the Cappy must have been thrown to get to this position. So now all we have to do is just make a return animation to make Cappy come back. So here is where we set some things. We set cap thrown to 0.4. That's what I like to do to signal, to make us think that he's coming back. And then we need an if-else statement. And this is going to be basically saying if distance to Mario. So if Cappy is far enough away, where is it? Where is distance? There it is. Distance to something. Distance to Mario. If that is greater than 25, then that means we're far away from Mario, so we need to keep coming back. Otherwise, we've reached Mario's head, and we can hide and do this stuff. So now all we have to do is add in the return animation. So the way that I like to do this is we get our change Cappy X stuff. We get our change Cappy X. And then we need another one this time for change Cappy Y. And we're not going to be using this stuff that we used before. We're going to make a new thing. So we're going to get multiplying. So we're going to do something similar, though. We're going to be getting a divide, just like we did before. But this time, we're going to be doing x position of Mario. X position of Mario. Whoops. X position of Mario minus X position. X position of Mario minus X position. Divided by absolute value of X position of Mario minus X position. We're going to do that. So that is going to give us a number between 1 and -1. So it's going to be either a 1 or a -1. And that we're going to multiply by 24. You see, it's 1. That number is 1 less than the distance. That is what we want. You need this number here that you're multiplying by to be less than the distance to Mario. Because if you make it more, Cappy could potentially overshoot Mario, and then he could be jittering back and forth. So you got to make sure that it's like that. So then you're going to do the same thing for the Y, and then you're just going to stuff this thing right in there, like that. And that is our script. And then you need to duplicate this one more time and change these things to Y position of Mario and minus Y position, minus Y position, no, not X position, Y position, Y position, and stuff this thing right here. Nope, not right there, because that got rid of our multiplied by 24. Now, where did that go? Where did that go? Oh, I don't know where it went, so I'll just get a new one. Multiply by 24. Multiply this by 24. Stick that right there. And that is going to bring us closer and closer to Mario every frame until we get close enough then we hide it. And stick this right here. There it is. So let's get rid of that. And that is the exact code that I used to make Cappy. This should work. Let's see. So I can walk around and jump and do stuff, and I throw Cappy, and he stays out for a little bit, and then he comes back, and then he hides. And that is exactly what we need. And another thing that we need to add is we need to add if we're holding the Y key down or not, then that'll make Cappy stay out for longer. So basically how we do that is we need to get an OR statement. So if cap thrown is greater than 4, so if we're allowed to throw our cap and frames Cappy has been out is less than 30, or, and then we get an and put this in here. If key Y pressed equals 1, key Y pressed equals 1, and now you can make this number as big as you want, 90. I'll say 90, and then you put that in here, and that will make it so that if I just don't hold anything, he's going to come back after 30 frames. If I press and hold, you see this, he's going to stay out longer than 30 frames. He's going to keep going and going and going. He's going to stay for as long as I hold it until it gets to 90, and then he comes back. Or I could just hold it for as long as I want up until 90. So after 30, say I did, so around here, I just let go and he comes back. So that's how you make it so that he can stay out if you hold the Y key. And one last thing that I like to do is I like to go into Mario here. And we're going to go back to this if key Y pressed equals 1 and cap thrown equals 0. Not only do we set cap thrown to 0.5, but if Mario's in the air, I like to give him a little speed, a little height boost. So the way that we detect if Mario is in the air or not, do you remember? We use our falling variable. So if Mario's on the ground, then it's going to be 0 or some really low number. So all we have to do is detect if Mario is off the ground. So if falling is a number greater than 3. So put that in here and give Mario like a little speed boost, like a little height boost. So say 5 or something. I can't remember what I used earlier. But let's see. So when Mario's just sitting on the ground and we throw it, he doesn't get any height boost at all. So if I jump and then throw it, now that was kind of low, so increase the number. There, you see he got a little speed boost like that. There, you see, I'll throw it, and he got a little bit of a speed boost. So it'll probably be more noticeable when the frame rate's faster. So that's how we do that. And also, you can just set speed X, set Mario speed X to Mario speed X times 0.5. That'll slow him down just a little bit because he has to take a little time to throw his hat, right? Mario speed X times 0.5, and that'll just slow him down just a little bit. So that is all I wanted to show you in this tutorial. Once again, sorry that it is so slow because I am recording. If I tried this project after recording, it's going to run really smoothly, and I assure you that it will run pretty well for you if you attempt to do this. If you attempt to make this without recording. So, also, don't have any other projects open while you're playing one project, because that will also slow you down too. So close all other projects before you play this. So that's all for the second tutorial. I see I've been running for 40 minutes. That is not a very good improvement at all from the last tutorial, but it's okay. So thanks for watching this tutorial, and I'll stay tuned for the next one. I hope you learned something from this, and we got Cappy done.